Good afternoon, everyone. This section is on logarithmic functions, or we just call it log functions for short. What is a log function? Well, the formal definition, it says if x and b are positive numbers, such that b cannot equal 1, then y equals log base b of x is called the log function base b, where y equals log base b of x is equivalent to b to the y equals x. So if you recall from the last section, this was something like an exponential form right here because we have a base, right? The letters are kind of switched up right here, but this is the log form. Very important. This b base, this is a subscript right here. This does not mean log of bx. No, two different things, okay? Subscript means the letter's been dropped right here, okay? That does not mean it's b times x, so don't do that. That's incorrect right there. So that's why we say log base b of something. And again, like I mentioned before, this is equivalent to an exponential form. So hopefully you've gone over this section 9.2. Why? Because in order to solve any kind of log function or equation, what do you have to do? You're going to have to convert it into exponential form, but we're going to get to that in a little bit. So log functions, they're just used, again, to describe very large data that's growing very quickly, like exponentially, again, like with earthquakes, for example, with the Richter scale that measures the intensity. Whenever they say, oh, there's an earthquake that had it was on the Richter scale of 2.0 or 3.0, or from 2.0 to 3.0, that's not by a linear factor of 1. That's actually a logarithmic factor. So usually things that are blowing up super hard or increasing on a graph super quickly or decreasing super quickly, they use log functions because it kind of smooths it out and it makes it a little easier to look at large pieces of data over large amounts of time. So this section is very straightforward because all we're talking about is converting from log form into exponential form and vice versa. As I mentioned before, that's important because when you solve log equations, the way you do it is you convert it from log to exponential form. So again, this you just need to remember right here. Log base b of x is equivalent to b to the y equals x, and you can go from one form to the other. So let's say we wanted to write this out. Log base 2 of 64 equals 6. We want to write that out into exponential form. So what are we trying to do? We're just trying to go from here to here, like that. The easiest way to do it right now is write the definition, right? I need a y equals right here. Y equals. So we have y equals, and this is log base b of x, right? So all we're trying to do is you're just matching the letters, the b with the b, x and x, y and y, and you just fit it into this format right here. So the exponential form would be, well, it says b to the y equals x. What's b in this instance? It's 2. What is the y in this instance? Well, if we look, it's the 6. And that's equal to x. What was x in this instance? 64. This is exponential form. That makes sense, right? 2 to the 6th power equals 64. Again, where am I getting these numbers from? You're just comparing the formula, right? We're going from this form, log form, to exponential form. You just match the b's with the b's. The b in this case was 2. The y with the y's. The y was 6. And the x with the x. It's equal to x. What was x in this instance? It was 64. And that makes sense, right? 2 to the 6th equals 64. It doesn't matter how crazy the problem looks either, okay? Like if I have, say, log base 10 of 100, or actually, let's do 1 over 100 equals -2. And again, we want to write this into exponential form. So to start, let's write the definition of a general log. It's y equals log base b of x, right? And we're trying to go to b to the y equals x. That's what we're trying to convert it into. So you start matching up the letters. Okay, so what's my b in this instance? 10. So I have 10 raised to some power. Well, it says y. What's my y? -2 equals x. What's x? 1 over 100. This would be your answer in exponential form. Does that make sense, though? 10 to the -2 equals 1 over 100? It does, right? Remember, because how do you deal with negative exponents? You flip them and you make them positive. So this becomes 1 over 100. So we get back to that right there. So again, it does not matter what your log looks like. You just need to remember log base b of x equals y is equivalent to b to the y equals x. If you write that down on your sheet of paper as you're doing these homeworks, it's going to be very straightforward. What if we have one like this? We have log base y of, log of y, log of base y of z equals x. So again, we want to convert this into exponential form. Don't get all discombobulated and go, oh, well, there's a y down here now. I have the y right here. What do? No, pay attention to the order of the letters. That's all you care about. The b is this, correct? The x is right here. The x is this piece. And then lastly, we have the y is this piece right here, right? So let's just match it all up. So b, what's the b in this instance? It's y. And then what is the y exponent component right here? That is the x. And that is equal to what was your x in this case? It was the z. So this one seemed a little confusing because the letters kind of look similar, but they were out of order. But again, if you write the definition down, you just match the letter with whatever, and you don't care what it looks like. Now, what if we had, say, let us do log base 7 of 1 equals 0. So again, we have y equals log base b of x. And we're just trying to go to b to the y equals x. Again, just match up your letters. What's your b in this instance? The b was 7. What's your y in this instance? It was 0. What was x in this instance? It was 1. That makes sense to write 7 to the 0 power is 1. So if you have all numbers in your log expression, when you put it into exponential form, it should work out algebraically. For this one, we couldn't tell, right? It's more difficult because it has all letters. So if part of your log expression has letters, it's going to look kind of weird, right? You're not going to get something that makes mathematical sense like this one does right here. Now, what if we have, say, something like this. We have a special kind of log. We have this right here, natural log of x. You might see something like this. This is called the natural log of x. That's how we say that. And it's just a special type of log function. It is just a normal log function with a base of e. Remember e from the last section, that financial number that came up? That is what a natural log is right there. So if you have to evaluate a natural log, you convert it into its equivalent log form. What do I mean by that? Like if I have y equals, I'm sorry, not y equals, natural log of 1 equals 0. And let's say we want to put this into exponential form. Well, what we need to do first is rewrite it with a log base e. So this just becomes log base e of 1 equals 0. So again, I'm just changing the ln to a log. It now has a base of e. The 1 and the 0 stay the same. This is now y equals log base b of x, right? And again, what are we going to? We're going to b to the y equals x. So let's do that. What's the b in this instance? It was the e. What's the y in this instance? It was 0. What's the x in this instance? It is 1. That makes sense, right? E to the 0, or 2.71. Remember when we typed into the calculator, 2.71 to the 0th power is 1. So that would be your answer in exponential form. Now, what if we go in the reverse direction? What if we wanted to write the equations in log form? So now we're going from the right side to the left side. Okay, we want to go from exponential form to log form. If I have 3 to the 4th equals 81. So we're going to go from this to some log thing. How do we do that? Let's write the definition, right? This is b to the y equals x. We're going to do the similar procedure of just writing it out or matching the letters, right? So, okay, what's the y in this instance? 4. Well, log doesn't change. What's your b right here? Oh, it's 3. What's your x? 81. This is your answer right here. So when you're typing this into the Alex homework, there's probably going to be a tool that lets you lower the numbers. So remember, this is a subscript. You're moving that number down. It's not log of 3 times 81. It's log with a base 3 of 81. What if I have 10 to the 6th equals 1,000,000? Again, we have b to the y equals x, and we want to convert it into log form. So what's the y in this case? 6. So we have 6 equals log. What's your b? 10, right? Base 10 of x. What was x? 1,000,000. What if I have 1/5 to the negative 1 power equals 5? Again, this is still b to the y equals x. B to the y equals x. And then we need to convert it from that into y equals log base b of x. So let's do that. What's the y right here? Negative 1 equals log. What's the base of 5th of what's x? X in this case was 5. And that's all that there is to it. So it's important to be able to convert from one form to another. And like I said before, how we're going to solve these in the next section, you are going to convert them into exponential form no matter how complicated they get. And we can partially solve basic log functions like that as well. So let's say we wanted to evaluate or simplify the log expression, not function, without a calculator. Let's say we have this right here, log base 9 of 9 equals what? Now you may be asking, why is it saying without a calculator? Because you may notice the calculator has a log button right here. It also has an ln button, right? But the problem is whenever you do log of something in a calculator, you cannot change the base. Anytime you press the log button, which I'm doing right now, right here, it's only base 10. It will always be base 10 on any calculator when you press the log button. So the second the problem has a base other than 10, you can't just do log of that. Like if I type like log of 9 and hit enter, that's incorrect. This log of 9 that we just typed into the calculator, what it did was it did log base 10 of 9 right here. That's not what we have though. We have log base 9 of 9. So again, anytime y'all press the log button, it's base 10 right there. And no, you can't, I can't move the cursor down here and change that to something else. Okay. So be very careful with that right there. The natural logs, yeah, if you have natural log of a number, sure, you can do that. Because remember, natural log always has a base of e right there. But in this case, we're trying to work this out without a calculator. How do we do that? Convert from log form into exponential form. We have y equals log base b of x. And remember, that's just equal to b to the y equals x. So what do? We have the base, which is 9. We have 9 raised to some power. We're going to put question mark. Or if we want, we can change that with a y. I'll do that in the next problem. Equals x. X is 9. So 9 raised to what power gives us 9? Well, the question mark's got to equal 1, right? That would be your answer right there. So again, the trick is just convert it from log form into exponential form. Figure out what power you have to raise that to in order to get your solution. And that makes sense, right? 9 to the first is 9 right there. What if we had log base 2 of 8? And again, we want to figure out what is this right here. Now, a lot of the times they just say evaluate this, and they don't even put an equal sign. But what you can do to make it a little easier is put equals y. Just throw that in there. Why are we going to do that? Because now we have this, right? We have y equals log base b of x. And again, we just want to convert that into exponential form. B to the y equals x, so we can solve it. So let's match that up. We're going to have 2, because that's the base, raised to some power. That's the y, b to the y, right? Equals x, 8. So then you ask yourself, oh, 2 raised to what power gives me 8? It's not 4, right? 2 times 4 is 8. 2 to the 4th is 16. So remember, this is an exponent. So y equals 3, since 2 cubed is 8, right? So that is your answer right there. What if we had log base of a half of 8? And then we're going to say, oh, that's equal to y. So we want to figure out, what is that? Log the base of a half equals 8. Looks a little weird. Let's try to work that out right there. But again, convert it. Remember, we need to go to b to the y equals x, right? That's what we need to convert from here into here. So what would that equivalent exponential expression be? So we're going to have b, right? This is the b, that's 1/2 raised to some power of y equals 8, like that. So what in the world would do that right there? Very tricky, right? So we know how are we going to do this? We're going from a fraction to a whole number via an exponent. How do we do that right there? Well, we know if we think about it, we know that 2 cubed is 8, right? Because we just saw that. If we could only somehow make this 1/2 into a 2 via an exponent, how can we do that? Remember what flips numbers exponentially? It's when the exponent's negative. So if I have y equals -3, would that work right here? How do we check that? Well, what's 1/2 to the -3rd power? Remember, when you have an exponent that's negative, what do? You flip this piece right here that it's being applied to. Well, if we flip that, that becomes 2/1, and that becomes a +3 now. So now we get 8. So we get -3 as the answer right there. So if you're going from a fraction to a whole number via exponent only, your exponent will have to be negative, because again, that's going to force it to flip, and then that will make it positive, and then you'll get to your whole number. So let us try. Let's say we have log of 1/10,000. So remember, this is how the problem always begins. They don't put equals anything. So let's put equals y. Why are we doing that? It's so we can convert it into exponential form. If you notice right here, they didn't give us a base. If they don't give you a base, it's an automatic 10 right there. Kind of like, when they do square roots, right? Like if we talk about the square root and they don't put anything here, what is the index automatically? 2, right? Same situation with the logs right here. If they don't give you a number, it's automatic 10. Just like in the calculator, when you press the log button, it's 10. So now that we have this, let's convert it into exponential form and try to solve it. So B, so this is going to be 10 to the y power equals 1/10,000. So now we're going from a whole number via exponent to a fraction. Well, this is kind of like the reverse of what we did with the last problem, right? We went from a fraction to a whole number via exponent. How do we do that with a negative exponent? Guess what? Still got to do right here. So we are going to have some kind of negative exponent. So think for a second. 10 raised to what power would give you 10,000? Well, we know 10 squared is 100, right? 10 squared is 100. 10 cubed is 1,000. So 10 to the 4th is 10,000. So how can I make this 1/10,000 if I made the 4 negative? So if I got y equals -4, that should work, right? Because if we check that, we would get 10 to the -4th equals 1/10 of the 4th. But that's 1/10,000 right there. So this would be your answer, -4. So when you go from a whole number to a fraction via exponent, it also has to be negative. What if we have, say, log base 8 of the cubed root of 8? So even crazier, right? Now we have radicals in there. So again, let's put that equals y. Now, before we even start trying to solve this, let's rewrite it. Anytime y'all have radicals, you need to write them out in exponential form. Okay? You should do that right there. So this is log base 8 of 8 to the 1/3 power, right? Equals y. Then from here, you could say, oh, I know what this is. We know what the cubed root of 8 is, right? You could have skipped this step, but you should do it for practice, because that will be important when we solve more complicated log functions in the upcoming sections. So what is the cubed root of 8? Let me just ask yourself, What number can I multiply times itself 3 times? That gets me to 8. It's 2, right? So we have this. Log base 8 of 2 equals y. So now let's convert it. B to the y equals 2. So now we're going from a whole number via exponent, not to a fraction, but to a smaller whole number. Well, what's going to get us there? Some kind of root, right? What kind of root? Well, it's probably going to be the cubed root. So the square root of 8 does not equal 2. The cubed root of 8 does equal 2, right? Remember, how do you write roots in exponential form? Or in this case, how would you write the cubed root of 8? It would be 8 to the 1/3. Remember, the index becomes the denominator of your fractional exponent. So y in this case is equal to 1/3. Like I mentioned before, it's important to write these out in exponential form. If you notice, this matched up right here. We kind of already saw the answer right there. And that's actually a special property of logs that I'll mention at the end. If the base and this match, whatever that exponent is on the outside right there, that's your answer. But like I said, I'll write down those general rules or little quick shortcuts at the end of this section. If you forget them, though, you can always convert to exponential form. It's going to work all the time. What if we have log base pi of 1? So again, let's put equals y. So it looks super weird, right? Because we have a pi. Will we be able to work it out? Yeah, let's convert it into exponential form. This becomes pi to the y. What's y right here? It is going to be y, because we don't know what it is, equals 1. So pi raised to some power gives us 1. What can do that? Remember, it's 0, because anything raised to the 0th power that exists becomes 1. Pi to the 0 is 1. So this one looks crazy complicated, but this is one of the easier ones. This is also a little special property that will pop up, but again, I'll write that at the end. What if we have natural log of e to the 7th? So again, we're going to put equals y because they don't include that. How are we going to work these natural logs? You want to convert them into a log. Remember, natural logs are logs with the base e. This becomes log base e of e to the 7th equals y. So now that we have it in log form, right, let's convert it into exponential form. B to the y, what's your b? E to the y was y, equals e to the 7th, right? Remember, all this right here, that is your x right there. So now we need to figure out e raised to what power gives me e to the 7th. It's just 7, right? I know it looks goofy, but that would make it a true statement, right? If I plug 7 into here, I get e to the 7 equals e to the 7, right? Because that's what the equal sign means. It must be true on both sides. You have to have a true statement. It must be the same thing. This is another little property that kind of pops up. Again, I mentioned it before. If the base in this match, whatever's left on the outside, that's the answer right there. What if we have natural log of 1 over e to the 10th? And again, let's put that equals y because they don't give it to us. So remember, to convert or work out your natural logs, convert them to a log of base e. So this is log base e of 1 over e to the 10th equals y. If we convert that into exponential form, it's b to the y. E to the y equals x, which is 1 over e to the 10. So now we're going from a whole number or a whole something or a whole, I'll say whole real number, a rational number to an exponent, right? So how do we do that? We got to somehow flip this, right? How do we flip fractions via exponent? You make the exponent negative. If we get y equals -10, what would that do to this? Well, if we plug -10 into here, how do we resolve that or take care of it? We have to flip this, right? So now we get that expression that was on the right-hand side. So this is your answer right there. So again, we're going from some kind of whole number or rational number to a fraction where they're flipping it. That exponent via exponent, the exponent has to be negative. So now some properties with these logs that may come up that I've been mentioning before. Like these are just little shortcut formulas that are useful to remember. Like if you have log base b of 1, it's automatically equal to 0. So you don't care what the base is, okay? It could be 2, 3, 4, 5, 6, 7, 8, 9, 10, 80 million of 1 is equal to 0. Because if you convert this into exponential form, why is this always true? We get b to the 0 power equals 1. This will always be true, right? That's why that property works. If you have log base b of b, and I'll say to the m like this, then your answer is just m, because these kind of like undo each other. So you're left with the exponent. If we have b raised to the log base b of m, so now this whole expression is the exponent, and it's being raised with the base of b. Again, if these match, then your answer is just m. So an example of this one right here is like, say if I have 7 to the log base 7 of 15, your answer is just 15, okay? Or with this one right here, if I had log base, and I'll do like 13 of 13 to the 5th, your answer is just 5. So if these match or those match, that's what's left over every single time. Some other ones that may pop up or quick ones to remember are the natural, like with the natural logs. Like if I have natural log of e to the m, that's just m. These cancel, it's like they undo each other if you want to think about it like that. And so again, like if I had natural log of e to the, I don't know, 10th, it's just 10. Even if I had the natural log of e to the, say if I said 3x squared minus 2, like that, it's just 3x squared minus 2. Another one that may pop up is natural log of 1. That's just equal to 0 all the time. And you can check that in your calculator. You can type it in. Or if you have natural log of just e, that's just equal to 1. That also pops up. Anytime these expressions pop up as you're working out a problem, we write them from this form into this form, right? It's easier to see a 0 or to work with a 0 than natural log of 1. Or it's easier to see 1 versus natural log of e. So that pretty much covers 9.3. You need to know this right here, this equivalent expression right here, in order to work the future sections, okay? So please go over this before you look at the material for the next section. If not, you're going to have a hard time solving these log problems. But again, if you remember this, it's very straightforward, right? Because what do we ultimately do? We just match the b with the b, the y with the y, the x with the x, and we worked it out, right? Or we just rearrange the problems. So when you're working these problems out, make sure you read the directions, because if it says just write it in its equivalent exponential or log form, don't solve anything. You only solve it when it says evaluate or simplify the expression, okay? Because if you go too far, meaning solving it, even though it's asking you just to rewrite it, then it's going to tell you that you're wrong, okay? So make sure y'all read the directions with this.